Welcome to lesson number 6 on organic reactions. Our lesson objectives: identify the type of reactions and determine the product of substitution and addition reactions. Organic reactions are how we make these organic molecules that we've been discussing in this unit. The first one we're going to look at is the combustion reaction. And so for most of the reactions, you have to be able to identify what the reaction is. And so for the combustion reaction, it's an organic compound. In this case, we have methane, CH4. So we know it's organic because it has carbon and hydrogen. And we're going to burn that in the presence of oxygen. And our product, what we're producing, is going to be carbon dioxide and water. And so a good way to identify this is oxygen is always going to be a reactant, and CO2 and water our products. Recall that our combustion reactions take place or are listed on table I, and you can see we have oxygen as our reactant, we have CO2 and water for our products for all of these reactions. So the only thing different is that we're changing the organic molecule, the substance that we're using or burning. The substitution reaction, the name says it all. We're substituting in one element for another. It's similar to a single replacement in that two atoms switch. The first compound here is a saturated alkane, single bonds. We have a diatomic element, and we see that one H is going to switch spots with one of these elements here. So let's see an example. So if we have ethane, this is our alkane, saturated single bonds. We have a diatomic chlorine. And so since there's no place for the chlorine to be added on because they're all single bonds and carbon already has 4 bonds here, what's going to happen is that chlorine is going to substitute in or take hydrogen's place, and hydrogen comes out and is going to take chlorine's place. And so the resulting product is going to be now a substituted hydrocarbon. This is chloroethane, as the chlorine attached as a branch. And then we have HCl as another product. So in the substitution, again, switching spots, and we end up with 2 products. In the addition reaction, we have a alkene or alkyne. So we have a double or triple bond, so in this case a double bond, which gets broken and is going to produce more bonding sites so we can actually add these diatomic elements. So for the addition, this substance, this organic compound must be unsaturated, meaning a double or triple bond. So let's look at an example. So here we have an alkene, we have our double bond, and we're trying to add diatomic fluorine. And so what's going to happen is this double bond is going to break, and it's going to give us 2 more bonding sites. And so now we can add our 2 fluorines to that, and so we're left with 1 product in the addition reaction. So it's a synthesis type reaction. Let's check your understanding. Can you identify the type of reactions, and can you determine the product of substitution and addition reactions? The next reaction is the esterification. This is how we form esters, which are smells. And so to identify the esterification, we're going to look at the product, and here we have the ester. Recall that from table R, the ester is the C double bond to oxygen and then another oxygen in the parent chain. And so we see that here. So this is our ester. So forming an ester would be esterification. And so here are some common esters and the substances or the smells they're associated with. Fermentation is the process of making alcohol. So it's the enzymatic breakdown of sugar into, so here's our sugar or glucose, into alcohol, ethanol, and carbon dioxide. So we can identify a fermentation reaction by looking for the alcohol as a product, and we have the OH here, and from table R we can see that's our alcohol, and CO2, which is our carbon dioxide. Saponification is the process of making soap, and so it's the hydrolysis of fats using a strong base. And so we produce soap and an alcohol as a product. And so we can recognize the alcohol by the OHs, and the soap will actually say soap, so you know that you're making a soap molecule. And if you've ever seen the movie Fight Club, at the end, that's actually what they're making. They're rendering fat to produce soap. So looking at the reaction, On the reactant side, we have NaOH, that's a strong base, and then we have our soap as a product. The next reaction is polymerization. This is the formation of long chain molecules called polymers from small repeating subunits called monomers. So if you think of a chain is just a repeating pattern of the same structure, and that's what a polymerization is. Polymers can be natural, like proteins, or artificial, like plastics. So here's some examples of polymers. Starch, which are long chains of sugars, proteins, which are long chains of amino acids, and cellulose, which are made of repeating units of sugar. So one type of polymerization is the addition polymerization, where we're adding small double-bonded alkenes together by breaking that double bond to create a larger chain. So how do you identify a polymerization? Well, we look for a monomer, so an alkene here, with an N, and N represents a large number, and it means we're repeating this over and over. So here's an example in this animation of a polymerization. So the double bond breaks, gives us bonding sites, and they attach to form a longer chain called a polymer. Poly means many. So again, look for that N being a very large number. The next type of substance we're going to produce are some of our useful fossil fuels, things like gasoline and propane, and this is done through a process called cracking, where we're breaking large hydrocarbons, so long chains of C's and H's, into smaller chains by heating them. So fossil fuels are cracked into many components, such as octane gasoline, we have propane, etc. And it's done using this kind of simplified version here, where we're taking crude oil, we're going to put it in a furnace, we're going to heat it, and then it's going to be distilled or separated out into the various components at various temperatures. Let's check your understanding. Can you identify the type of reactions? At this point, you should be able to identify the type of reactions and determine the product of substitution and addition reactions.